very much for holding us up.
All right, I'm Scott Allen Miller, and we are doing for SpiceCorps DFW in conjunction with CBionk, who was already here and did their other presentation. We're going to talk about cloud computing as an architecture as part of our ongoing architecture series. So this is going to be a purely technical discussion today. So this is modern scalable architectures for elastic computing. Woo. Oh, yes, okay, my clicker works. All right, so when dealing with cloud, right, we're used to hearing the term cloud all the time. Cloud. And there's two uses of cloud. And this is very important. This is what I want to help people with differentiation. There's cloud computing. Cloud computing is an actual architecture. This is a very technical term originated by Amazon in the creation of EC2. And so it's a very specific thing, right? When people say that they're confused by cloud, they're not, people use cloud and it's kind of an ambiguous term. Cloud is not actually an ambiguous term. It is incredibly specific. But there's another term, cloud services, which people refer to as the cloud, which refers to any type of service that is provided over the internet, or the internet being the cloud. So marketing departments love to use the term cloud services, or to use the term the cloud in reference to cloud services, because it allows them to reference basically everything. A website is a cloud service. It comes over the internet. Email is cloud because it comes over the internet. Everything comes over the internet, so you can just apply it wherever you want. So this term isn't particularly useful. It only differentiates from things that don't go over the internet. So learning to how to use it and how others are using it is very important. So cloud services, the marketing term, these are some really common applications that people that are delivered over the internet, but are not necessarily made with the cloud architecture. Google Apps. Google has actually, when people talk about cloud, they often use Google as the example of cloud. Google has stated that they do not use a cloud architecture in making Google Apps. So the most prominent example of the technology is actually wrong. Salesforce is delivered as a cloud service. If it uses cloud, it's under the hood. Office 365 is built on traditional technologies, or was originally. Wave Accounting, Basecamp. These are all, we think of these as applications that we get over the internet. In no cases are we using cloud. If there's any cloud involved in them, they are used by the providers and not used by you as the end user. Okay. So cloud computing. This is what we're actually going to be discussing. It's an architectural standard. Amazon originated this with their Elastic Cloud Computing product, or EC2, in 2006. Before that, we used the term the cloud, but it was a very general term. It was normally used to refer to the piece of your network diagram outside of your organization. Traditional network diagrams would actually have a line going out from your WAN link into a cloud, because it was just a cloud of routers that connected other organizations. So that's where the term actually kind of came into common use. The National Standards Institute from the United States government came out and said, okay, there's a lot of confusion around the cloud. So they actually wrote a standard that was ratified through the National Institute of Standards and Technology that defines what cloud computing is. And they came up with 5 essential things that define cloud architecture. The first is that it's an on-demand self-service. That means you're auto-provisioning, right? You're able to create new instances or expand without having to have any significant input from an IT department, for example. You don't need to go to technologists to have this happen. It will on-demand grow itself. Broad network access. It's available one way or another over a network. It has absolutely no connection to the internet, right? It could be over the internet. It doesn't have to be. That's not part of the standard in any way. Resource pooling, meaning the resources of multiple systems are shared between multiple end users, applications, or whatever. But it's about sharing resources is a key component. Rapid elasticity. This is related to on-demand self-service, but it is not directly connected. This means that the system is able to grow at an architectural level as demand requires. And the last one is measured service. This is one we think about a little bit less often, but it really is part of it that when using a true cloud architecture, there is some means of recording which users of that system are actually using what capacity of the system. It's not something we think about too often, but it's certainly I'm having a real hard time with this clicker today. Okay, I do believe I've now. Oh, there we go. And my because we're not plugged in, I'm getting dimming all the time. So this is the actual kind of overview. This is from the NIST. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. All right, so in the NIST standard, they broke this down into 3 as-a-service components. And these are the different service models, the different ways that you can have the application delivered. And CBON, Kevin from CBON, just spoke and talked about all 3 of these. So this is very well understood in the industry that these are the terms that people are using. Infrastructure as a service is what we refer to as actually getting computing resources delivered to us as a service. And this is the most well-known and most easily explained component of cloud computing. The big players here, Rackspace, SoftLayer, Terramark, GoGrid, these are companies, and CBON, of course. You're able to go to these companies and actually get a server or 1,000 servers or whatever, and it's available as a service. Platform as a service, this one's a little bit more esoteric and people are not used to this as much. And traditionally this was called grid computing. Calling this platform as a service and lumping it with cloud services is a newer thing. Grids existed before the term cloud existed. Big platform as a service players today, Heroku, which is an independent player, App Engine, which is provided by Google, and Elastic Beanstalk, which is a really cool name. And that's Amazon's platform as a service.
That's like a name for everything.
It is like a name for a band. Yeah. And so platform as a service is really up and coming as the new place that the cloud is really growing and that a lot of opportunity is, because it actually provides an application layer where you can deploy applications. Instead of having to build your own server and put applications on top of it, it's a layer where you just deploy your applications and they take care of it. So it's typically built on infrastructure as a service internally for a cloud provider.
Who's Heroku?
Heroku is an independent platform as a service. They're no other person. Heroku.
I mean, that's what I'm saying. What do they provide? I mean, what's their service?
They provide the Heroku platform as a service platform.
It does what?
It's a platform as a service. Platform as a service is the product, right? Just like infrastructure as a service provides computing containers, so operating system instances, platform as a service provides an application platform on which applications run. So it could be a .NET type platform, it could be Perl, it could be Ruby, it could be Java. Heroku provides support for like 15 languages, including some really cool ones like Clojure, Scala, Ruby on Rails. So they do some, Heroku really targets the highly advanced platform as a service. Okay.
Battery dead?
I don't know. Oh, there we go. Okay, and the last one, software as a service. I wrote this because it's really impossible to give examples of this, but it's a highly contentious gray area. The reason the software as a service is tough is because as an end user, you have no way ever, if you're getting something as software as a service, to know if it is a cloud or isn't a cloud. In all of these cases, you can get infrastructure as a service that is not cloud, right? If you have a company that supplies, we'll take Rackspace. Rackspace's traditional business is to supply physical servers in a data center. It is not a cloud, it's not virtualized, it is not elastic. It's physical servers that takes all kinds of human touching. It's still infrastructure as a service, it's not cloud. Platform as a service. This existed in physical grids before there was cloud. It's still platform as a service, but it's not cloud. Software as a service. I work for Niagara. Niagara has been doing software as a service since 1999, not on a cloud platform, right? Software as a service is every website is software as a service in some manner. Most of them are not on clouds, right? They're not elastic, they don't do that. So all of these are delivery models that apply to cloud, but they don't necessitate cloud. All right, deployment models. Private cloud, public cloud, hybrid cloud, and I really hate community cloud, but it's officially one of them. So private cloud is actually the least known, even though it's the most obvious. A private cloud is a cloud that you own as an individual entity, right? So your company decides they want to have a cloud platform. They can build one or buy one, doesn't matter. It's owned by an individual company, it's private. Public cloud, also could be called a shared cloud. This is what most people think of as cloud. In fact, they think of it so often that a lot of people don't realize that anything but public exists. They think that it's part of the spec, which is certainly not the case. The vast majority of clouds are private and always will be, right? The public ones are the big ones. They're more likely to be very large and well known. That's why we talk about them. Amazon, Rackspace, GoGrid, Terramark. So a public cloud is just a cloud that is shared between multiple organizations. Hybrid cloud is one in which you have both private and public and have applications that may move or have different components in each. Community cloud is a really silly term referring to, say, your company's HR department needs cloud resources and a partner's company's HR department needs resources, and you have a cloud together. Is that public? Is it private? Or because there's this certain organizations within that use it, they call it community. Whatever. It's a very silly term. And then acquisition models. Is it hosted or internal? This one's not part of the spec. This is something that I added because it really requires explanation. A cloud can be hosted, and again, much like public, people begin to assume that cloud means hosted, that it's provided by someone else, that it is located somewhere outside your company walls, and these are in no way tied to cloud computing. They're things that are common, but they are absolutely not part of the spec. So most common clouds that you're going to deal with, even private ones, are going to be hosted by a third-party provider. CBeyond being a great example because they just talked about the public and private offerings. And this is where a lot of the industry is going because, especially in the small business space, hosted clouds make sense. Someone else is taking care of that infrastructure, and you don't need that kind of scalability internally. But larger organizations today, the Fortune 100, for example, is almost completely using internal clouds. They may use hosted clouds in addition to internal ones, but internal clouds that exist completely within the organizational walls are a staple of the Fortune 100, and in the next 2 to 3 years, we're likely going to see them be almost completely ubiquitously deployed throughout the Fortune 1000. And we're going to see this in small businesses starting to happen more and more, too, as the cost and the ease of deploying completely internal private clouds just gets ridiculously easy. And I've worked with internal cloud models back when Amazon was just coming up with the EC2 product and the name cloud computing. I've actually worked with internal clouds of over 10,000 compute nodes on massive scale platform as a service providers. So we were doing this early on in the market. So IaaS, infrastructure as a service, is definitely what most people think of as cloud, and this is where the most interest in the SMB is going to be for a long time. There are 5 really principal players in the product, right? I'm not talking about hosters, I'm not talking about companies that are providing a service, but of actual products that are used to deliver those services. There are 5 really key products. OpenStack, XCP, Zen Cloud, CloudStack, and Eucalyptus are all open source, and almost all of them, or possibly all of them, rely on Zen virtualization as the underlying technology. And then VMware has more recently come out with their own cloud platform that obviously runs on the vSphere stack and provides cloud completely using the better known VMware technology stack. But all of these are available as something that you can put into your business today and run an internal cloud. It doesn't make cloud make sense for the average SMB, but these are available today. And Eucalyptus was out within months of Amazon releasing EC2, and it's completely API compatible. So if you have stuff that runs in Amazon, you can install Eucalyptus and use it immediately. OpenStack is the big player today, with Rackspace having just moved to OpenStack, and they're one of the big sponsors. Ubuntu uses OpenStack, and so if you're deploying Ubuntu, you can say deploy it on OpenStack, and it'll deploy it or deploy it on it. So OpenStack is really making a lot of ground today. With Zen Cloud Platform having a decent presence in very small companies because it's, you could deploy it with as little as 2 desktops running, I think, just for labs. But so stuff you can definitely get out and play with cloud today. You don't have to, spend a lot of money. You have a couple of little desktops sitting around, and you can get into cloud and get your hands on it. Okay. So cloud computing architecture, this is really IaaS that we're looking at here, but just to give it a visual, right? You have your traditional physical servers, you have your hypervisors, be it Zen, Hyper-V, vSphere, whatever, running on top of that server. Obviously you have one hypervisor on each server, is how it works. Then the cloud platform is really a hypervisor management layer or a resource management layer that crosses all those hypervisors and ties them into one. So when you have operating system containers, whether it's Windows or Linux or Solaris or whatever, and you install them on the cloud, the operating systems see the cloud as a single resource, right? They say, oh, I'm just on the cloud. They don't care what hypervisor they're on. They don't care what server they're on. They're seeing the cloud layer. So this single platform is managing the resources below it. And it makes, if you only had one server, this would be an extra layer of complication that wouldn't really make sense. But if you have a lot of servers, 4 might be very few, but if you have 400 servers and you need to be able to deploy thousands and thousands of OS instances to that, having a cloud management layer can do a lot to make that a lot simpler and easier for an organization to manage, because you're only looking at a single resource pool. If you were to then take us to the next layer, and I don't have a graphic for this, but look at platform as a service, we'd be taking this exact same architectural model and again putting another layer on top of here. We would move the cloud platform layer potentially. We could either remove this one or add another one above, or remove it and add one above. And have a layer across all those operating systems. That's another management layer that presents a single application platform instance to applications running on it. So applications that run on a PaaS see a single server that may have thousands of pieces of hardware and thousands of hypervisors and thousands of on top of it. So what are the benefits of doing this, other than kind of the obvious that there's abstraction? Rapid deployment of new systems and applications. This is really important, right? This is probably the key one. You're able to take a new system. You need a new Windows box. You need a new Linux box. You can have one in 30 seconds, right? 30 seconds. It used to be, oh, it took me 2 months to provision a new system. Now it's 30 seconds. And I might only need it for 15 minutes. When it takes 2 months, you can't do that for 15 minutes of use. But when you can do it in 30 seconds, you can. So it really changes the way you're able to work with your resources. Elastic horizontal scaling of system capacity based on current demand. This is what it was actually built for. This is when Amazon came out with EC2. It was specific for, and that's why it's called Elastic Compute Cloud, because the resources can scale elastically. And one of the specs is the auto provisioning, right? The self-deployment. And what is being used there is that applications, very commonly web applications, can sense their own capacity, see that they're getting busy, and say, oh, our 5 web servers are not going to be enough in a few minutes. We're getting busier and busier. Those web servers can signal the cloud platform and say, we're at capacity, or we're at 99% capacity, bring up another instance. Another server comes online in 30 seconds, and 30 seconds later we have 20% more capacity. As that one begins to fill up, it can signal the next one and say, start up again. Or you can have one that starts up 5 at a time, or whatever. It's automatic. Humans do not have to be involved. Nobody's throwing new servers into a rack every 30 seconds. The systems are self-provisioning as they go, as they need. And as they stop being busy, oh, we're only at 80% capacity, we're going to shut down the last couple of instances. We're always going to leave a little bit for capacity, but we're going to start shutting them down. And cost starts going away, and systems shut themselves down as they're not needed. And so that growing and shrinking is a key component to the value of cloud computing, not one that small businesses often take advantage of or are prepared to. Auto provisioning reduces the friction, meaning when you need to be able to get work done, you need a new system. Traditionally, you had to go to IT, you had to go through a lot of pain to get all your ducks in a row, get all the paperwork done. What cloud computing is often allowing companies to do, depending on policy of course, is allowing other departments or IT itself to have minimal amount of human interaction when new systems need to be spun up. The marketing department can just go and say, I need a new instance. They click. They have an auto billing system because of the metering, so we can do chargebacks, so they're not getting away with anything for free. But the capacity is already ready, and it just gets charged to them, and they can get new systems as they need them. It makes it just a much more pleasant experience for them, the way that you would buy things as a consumer. Cloud computing allows a greater efficiency because you're taking a lot of likely identical hardware platforms and combining them into a single resource. So it makes for standardization, which means you can have more systems managed by fewer SAs. And it just makes, it can be very cost effective in large scale environments. Like I was mentioning with the metering to different departments as it uses, this makes budgeting much easier because you're no longer in a position where you have to guess how much people are using or charge them for things they're not using, right? We can very easily tell exactly what different departments are using and charge them for it, which makes IT just a lot more transparent to other departments. You can go to the CIO who can go to the CEO and say, this department is spending this much money. It's not a question, it's a statement. It's very easy to move between internal and hosted models. This is really great. You have internal capacity for many things. What happens when you run out and you're physically going to run out of capacity? With cloud computing, you can have that hybrid model in place where you're suddenly offloading capacity to a third-party provider. CDN, Rackspace, Terramar, right? They have those kind of systems so that it can be very transparent. You're only using them when you've gone past your own capacity. And as I already mentioned, operational transparency. So what are the typical uses that we see it in? Web applications, especially ones on the internet. Those who get, people worry about the splash dot effect. Somebody links to you, and overnight you go from 100-page views to 100,000-page views. Well, 100-page views, you might be able to get away with a cloud instance that costs you $15 a month, and you're doing great. You're spending your $15, no problem. Suddenly at 100,000, you can't even begin to touch it, and you would need an architecture that would have been costing you $1,000 a month. Well, for that month, while that's happening, you can scale up with no interaction potentially, handle that need, and when people aren't looking at your website anymore, you scale back down. And so web is one of the most likely places where you're going to see application horizontal scaling used as a reason for cloud computing. Really popular, especially in larger organizations, is for development and testing systems. A lot of times you need a lot of capacity for very specific time periods, right? For the next month, we're going to be doing a lot of development, so the developers need a whole bunch of systems. When they're done, then the testing folks are going to need a whole bunch of systems for testing. And those systems would be very expensive to maintain all the time. You can just spin them up and down as needed. With cloud computing, it makes it much easier. And very large organizations where you're really leveraging scale. Cloud computing is about leveraging scale, whether it's internal or external. So, places where you're likely not to use cloud computing, because it certainly doesn't work everywhere. Small businesses. In almost all cases, small businesses are not in a position where they're leveraging scale. So while it's a very important architecture, for the SMB realm, it typically doesn't apply. It will begin to apply more and more, but there's always going to be a certain amount of general static computing in the SMB realm, and it's going to stay that way. But it's important to note that just because small business doesn't use cloud computing, it doesn't mean that we're not using systems that use cloud computing. It's just that we don't use it directly as small businesses. So we tend to use it indirectly. Things like if you're using Rackspace Email as an example, Rackspace Email relies on the Rackspace private cloud that they have running behind it. It's an OpenStack cloud with Zen as the virtualization. But none of that matters to you as an end user. It's software as a service that's being delivered via just software as a service. That it's elastically scalable doesn't matter to you, but it is. So it's that's a good example of software as a service that is a cloud product. Any system that has a static workload, if you know you're going to use 90% of a physical server all the time, every day, you don't want to go to cloud. Once you're predictable, you're going to be better on predictable systems. Having elasticity is a cost and overhead that you wouldn't want. So static systems aren't looking to move to cloud. Any small-scale organization, doesn't matter how big the organization is, but if you have small-scale system needs, cloud probably doesn't make sense. And any place that has a high disparity in physical environment. If you have specific architectural needs, you have some systems that need to be highly available, some that are very volatile, some that need to be Spark architecture or RISC architecture or Power architecture. Likely cloud is not going to make sense. You have too much disparity. But if you have a large number of systems that are all identical, every one of these is the same size Windows OS, the same size Linux OS, the same x86 processors with 8 gigs of RAM, cloud may be absolutely wonderful for that. What cloud is not, this is like the myth busting one, right? These are 5 things that people typically believe about cloud. And I hear people whenever they're making the discussions for, oh, we need to get cloud because of these reasons. High availability, low cost, massive computing power. It's just the thing that everyone's using, but the fear is that it's insecure. None of these are true. Cloud is not highly available, right? It can be. Nothing is stopping a cloud from being highly available, but high availability is in no way an intrinsic component of cloud. In fact, the Zen Cloud platform takes Zen, which has built-in high availability, and removes the high availability components when it becomes a cloud platform. So if you use Zen, your high availability as long as you turn it on. The moment you go to XCP, the cloud platform based on it, it disappears. So it's very important that people often do cloud for high availability. It's not generally designed for that. Could be, but not generally. Low cost. Cloud is not about being low cost. It is not cheaper. It is in fact more expensive because you're paying for idle capacity. It might be lower cost than owning a bunch of idle capacity, and that's why we choose it. but it's not on its own a low-cost architecture. If you have a choice between one server that's not cloud and one server that is cloud, that one server on cloud is going to cost you more, one way or another, because there's just more to it. It is not supercomputing. Someday we may come up with a way to combine cloud and supercomputing. Currently today, cloud is exactly not supercomputing. The idea of supercomputing is we take a whole pool of computing resources, say 100 servers, and we find a way to turn them into a single server with the power of 1,000 servers. That's great, and there's a big need for that. Cloud doesn't do that. Individual OS instances on a cloud only have the capacity, at max in theory, of 99% of one of the underlying servers. You never can use it to get more power than a single instance could have done without the cloud. It's about management and provisioning. It's not about individual capacity and performance. There's different models for that. Insecure. Cloud is just as secure or insecure as any other architecture. It's how we use it that makes it secure or insecure. So people fear cloud because it is insecure. There's not really a need to fear it in that way, but there's the regular concerns as there is with any computing, right? Your cloud could be secure, it could be insecure. A private internal cloud is likely to be absolutely identical in security to every other resource you have internally. But an external one that's public is likely to be less secure in that other people can access it, but probably drastically more secure in most ways because hosting providers of any scale have security resources far beyond any small business, and small businesses cannot compete on a security basis. Right? The statistics show that your data is 2 or 3 or 5 times more likely to be safe in a large company's hosting facility than in your own. Right? Nothing is more dangerous than a small business data center. And for everyone, right? Cloud is not for everyone, it's not for every application. Lots and lots of people are going to use it somewhere, but it's certainly not a panacea that's going to replace everything. That is not the case. It will become very popular, it will stick around, it's not going anywhere, but it's always going to be just one of many architectures that we choose for our business. Which really just leads me to what is the future, which is pretty much what I just said. Cloud is a staple architecture. It will be around. There is nothing about it. What cloud actually is very simple. It's a management layer that makes scalability more cost effective and easier so that we can scale in new ways. And that's about it. And these are really hard to read here, but when you look at the slide deck, they're very easy, and you can actually click on them. So these are mostly just references, National Institute of Technology, Standards and Technology, SpiceWorks, and then some of the products that we were talking about. So that is it, and thank you very much. I hope you enjoyed that.
Cool.